I hope I find you well. This is Jonathan. Okay, so one of my students asked for help with this question here, question number 5, and it reads: the cable exerts a tension force T of magnitude 143.4 newtons on the rectangular plate at point A. Calculate the magnitude of the vector component of T normal to the plate. Ignore the weight, and the answer was given to be 69.12 newtons. Now, um, let me fold my laptop. So now, just to probably draw a small sketch of the scenario that we are given, guys. If I have, let's just say this is the point A of the rectangular plate, and let's call this point, say, point M, and let's call this other edge of this plate, let's call that point P, right? Yeah. And we have another point B on the wall there, according to the situation that is given in question. I'm going to join these two, assuming that these are straight lines, guys. This is point B. And we are told that the force T is acting on the plate. So let me just assume that it's taking that direction, T there. And of course, this force has two components. One that is normal to the plate, and let me just a sketch, guys. So it's not up to scale. So let me try to pick a different color. If I pick that to be my Tn, the component of the force of T that is drawn to be normal to the plate, and let's have another horizontal component, some T parallel, but we are not concerned about that other T parallel, right? We don't care. We are only concerned about the normal component. All right. Okay, so we all know that if we have this angle to be theta, okay, I'm sure you agree with me to say that Tn, the magnitude of this horizontal component is none other than the magnitude of the force T cosine of theta. I'm sure this is basic, all right? If you resolve components of a force about a point, and if you are given an angle theta, it makes with the horizontal, then you have this scenario, all right? Tn, the component, if we have Tn as the horizontal component of that, but bearing in mind that Tn makes an angle of 90, all right? Now, Tn, which is the magnitude of the horizontal component, of the component that is perpendicular to the plate, is equal to magnitude of the given T cosine of theta, for which theta is the angle between them. This is nice. Okay, so let's call this equation 1. These are only magnitude. These are not force vectors, all right? That's why we don't have arrows or any drawn lines on top or below them. Now, but I want you to appreciate, guys, that let's have EAB let EAB be the unity vector along position along along AB, all right, and of course, let n hat be the unity vector perpendicular to the plate, all right, to the rectangular plate, all right. Now, I want you to appreciate that EAB is along the red arrow, okay, and N hat is along the blue line. All right. So from the definition of a dot product between two vectors, I will end up with EAB dotted to N hat. I should have their magnitude, right? Magnitude of EAB, magnitude of N hat, cosine theta. But the magnitude of these unit vectors is known to be 1. All right. So therefore, I'll have 1 times 1 cosine of theta. So in other words, in equation 1, I can replace the cosine theta by the dot product of these two unit vectors. Therefore, 1 becomes the magnitude of the component perpendicular to the rectangular plate is now equal to the magnitude of the given force T multiplied by the dot product of EAB and N. Okay. So now let's call this equation 3. So our task, we know T is given in the question. We are given the magnitude of T to be 143.4 newtons, if I'm not mistaken. So we are supposed to work out what is EAB and what is EN. Now, for us to find the unity vector along the line AB, which is our EAB, we need to find the position vector RAB from A to B divided by its magnitude. All right? Then this will give us this unit vector EAB. Now, the next question that we will ask ourselves will be, what are the coordinates of A and what are the coordinates of B, so that we can find the position vector RAB. So now if you go back to the picture in question, the x coordinate of A, as you can see, is just moving from 0, 7 units along the x. So A, in other words, has the x coordinate of 0.7. Let's just drop out the meters. It's fine. We can just put meters outside. And then the y coordinate, we are told that this plate is tilted 20 degrees into the xy plane. All right, so it's 20 degrees below the xy plane. So therefore, the y coordinate should be 20 cosine of 0.45. And if you punch all that in your calculator, you'll be able to get 0.423. All right, and now, and it's positive. Both x and y are positive, but we are going in the negative z sense, and therefore the z coordinate will be negative 0.45 sine 20, which will give you minus 0.154. Okay, and these are new meters. All right, now we do the same for B. Now B is right on the wall. If you check, so the x coordinate is 0.35, the y coordinate is a 0, and the z coordinate is 0.4, the height. Okay, so let's save that as well. So we have 0.35, then the y coordinate is 0, it's right on the wall, and the z coordinate is 0.4. All right, and also these are all meters. Therefore, we can happily say RAB, the position vector from A to B, is equal to the coordinates of B subtract those of A. So you are going to get minus 0.35i minus 0.423j plus 0.554k. All right, so this is the position vector from A to B, and therefore EAB, and we can as well calculate what RAB, the magnitude of this vector E, will be equal to the square root of this x component squared, y component squared, add those, and you're going to get, I think, 0.779, which is roughly 0.78. All right, so immediately we can calculate what EAB is. All right, is we take the entire vector divided by its modulus. So you are going to get something like minus 0. So we are saying minus 0.35 divided by 0.78. You get minus 0.449 I. We are leaving to 3 decimal places, kind of, so that we increase our accuracy. All right, and for the y term, you have 0.542j, and lastly 0.554 divided by 0.78, you get 0.71, say 03k. Okay, now this is our unity vector along the line AB. Our next task is to, because look at equation 3, it requires us to find EAB, which we did, and we need also the unit vector n. So what is n? So guys, remember we have a situation like this. All right, A is here, and we said M is here and P is there. Now if I take this vector, cross it to that, I will generate a vector, a new vector V, that is perpendicular to the plane containing these two. All right, that's the idea. And then after getting this vector V, I'll then take this vector divided by its modulus. I'll get n. So now, so clearly I need to know, in addition to the coordinates of A and B, I need also to tell what are the coordinates of M and P. So let's try to come up with the coordinates of M. Now M is sitting on the x-axis, and it is at a length of 0.7, and y is 0. Okay, let me just differentiate these. There should be a difference, right? 0 point and 0, 0. Okay, and P has coordinates. Now P has coordinates, the x coordinate, remember, is right below the y, so the x coordinate is a 0, and the y coordinate is similar to the y coordinate of A, which is 0.423, and as well, the z coordinate is equivalent to the z coordinate of A, which is minus 0.154. Perfect. Now with these we can tell, so the vector V, according to my small sketch here, is equal to RAP crossed to, so these are vectors, crossed to RAM. Okay, now so if you have two vectors in 3D, if you want to find the cross, it's effective to do that using the determinant form. So let's try to find these position vectors first. RAP, P there, is equal to, from A to P, we say coordinates of P minus those ones of A. So 0 minus 0.7, you have minus 0.7 I, and then 0.423 minus 0.423 is 0j, 0k, because those are identical. And okay, so let's try to get RAM. RAM from A to M, we say coordinates of M minus those ones of A. And then if you do that, you have 0.7 minus 0.7. You get, let's be careful here, let's be careful. So it will be 0I. There's no need for us to write anything for I. But for J, let's do coordinates of M0 minus 0. So that will be minus 0.423 J. Then lastly, plus 0.154 K. Okay, we are saying the coordinates of M minus coordinates of A. All right. So having found these two, we can now say therefore our vector V is equal to the cross I, J, K in determinant format, if you want to call it that way. So I, we place the, okay, let me just say RAP crossed to RAM. So RAP should come first on top, which is minus 0.700, and RAM should be at the bottom, which is minus, so it's a 0, it's a 0 here, because we don't have an X component there. So this is 0 minus 0.423, 0.154. Now, if you do this cross nicely, you are going to see, if you close I and J, you have 0 minus 0, which is a 0I. Then minus, for J, you put minus in advance. Then you close the entire top row, middle column, you have minus 0.7 times 0.1154 minus a 0. So it will be a positive, right? Positive 0.1078 J. And lastly for K, you get 0.296. Okay, so these are vector V, and immediately we can tell what is N. The unit vector is given by V divided by its modulus. Alright, divided by the modulus of V, which is equal to, if you do the math, you are going to get a 0.342 J plus 0.9397 K. Until now, we are doing great, guys. We are doing great. So, we now know what is N and EAB. So, therefore, equation 3, our equation 3, let's go back slightly and see and check equation 3. Equation 3, let's replace these things. We know T and we know these two vectors. So let's write down explicitly what we have. So therefore, the required term Tn is equal to 143.4 multiplied by the dot product of EAB and unit vector N. So remember, EAB was, we calculated EAB to be 0 minus 0.449 minus 0.449 I, then minus 0.542 J plus 0.7017013, okay, 7013K. This is being dotted to 0I minus 0.342 J plus 0.9397K. Now, this is now equal to, we can bring down 143.4, but if you do the dot, I dotted to I, because I dot j, I dot k will be zeros. I dot j will be 0, I dot k will be 0, because the angle between them is 90. So cos 90 will be equal to 0. So, but the cos 0, if I and I, the angle between I and I, the angle between I and I is a 0, so cos 0 is a 1, so that will survive. So minus 0.49 times 0, you get a 0. Then there's no need for us to say minus 0.449 I cross times dotted to minus 0.342j, because I dot j will be 0. So we move on to the j. Corresponding j from this first bracket will be minus 0.542j dotted to minus 0.342j. That will survive. And if you add it to the corresponding calculation for k, you're going to get something like 0.4820. Okay, and remember guys, these are all newtons, all right, because this was given as newtons. So if you punch all this in your calculator, you're going to get 69.10 newtons, all right, which is pretty much comparable to the given answer. If you go back to the actual problem, guys, the answer is given to be 69.12. The difference is due to the aspect of rounding off. So this is a correct answer, which is acceptable. It's within some accuracy range. All right, so this was the solution to the proposed to this given problem, guys. I hope you learned something. Enjoy the rest of your day. Bye for now.